Hello and welcome to my talk. My name is Katie, and today I will be talking about behavior driven development, a human centric approach to it. I host behavior driven development seminars here at Froglogic, but where I show people how can they implement behavior-driven development from the technical side, but today we will look at so-called social aspect of this approach to development. So maybe you have already heard about behavior-driven development. Maybe you have heard that it's an extension of test-driven development. But maybe you are now asking yourself, is this just the latest hype, some fashionable new approach, or is there some substance to it? What advantages does it bring me if I use it in my business, in my development team? What added value does it bring, and how is it better, or is it perhaps worse or the same that test-driven development? So this talk is going to answer these questions and focus on human interactions between the business and the development team, on the human communication and collaboration, how we communicate and how we understand or misunderstand each other, and then how behavior-driven development can help us to deliver the best results for the customer, for the business, and kind of make the work of the development team more effective. So I will start with this old meme, which is how the software development and how the real-life software projects work. So on one hand, it's what the customer really wants. On the other hand, it's how they describe it to development team or to the business analyst. And another source of miscommunication is how the business analyst translates those requirements to the development team, how they understand it, and how they design the solution. So there's, as we can see in this old meme, there is a frequent disconnect between how the business defines what they want to build, what they want to implement, what their requirements are, and how the development team understands the customer's explanations. And on the other hand, like the reverse direction, how the business understands the technical challenges their requirements present to development team, and at the end of the day, how they all communicate with each other and how they hash out those differences and those disconnects. So here is where behavior-driven development can help, because it presents us with a set of methodologies that help us to achieve shared understanding across the board. Shared understanding between the customer and the development team and the testing team, business analyst, and whomever else is involved in this process. It helps us tie the development with the business objectives, helps us to implement what the business wants, what do they really need, and at the end of the day to build a software that matches the needs of the users. And also, like, the added benefit of behavior-driven development is that we can make automated testing part of the process literally from the day one. So how does this really work? Here is some quick recap. What's behavior-driven development? As it's perhaps already clear, it's a kind of software development methodology, and it builds on test-driven development. It adds some additional layer of abstraction, additional set of rules, tools, and methodologies that encourages collaboration across different roles in the development team and also towards outside, towards the customer, towards the business. And those tools help us to focus on having a conversation about desirable software behavior, gives us the tools to speak to each other, to communicate, and to avoid misunderstandings, and at the end to deliver the software the business needs. And to do that, behavior-driven development uses a simpler domain-specific language. It's called Gherkin, and it's very similar to natural language, to English, with some set of rules and set of keywords. We will see a few examples of that later, but you can see like everybody can read such a specification and everybody can understand and contribute to it. And to further build on that, behavior-driven development uses examples extensively that help us clarify the requirements and to communicate them across the board. So this is some refresher in some graphical form. We all know this cycle of the test-driven development, which is initially we write a failing test. It fails because the code implementing the function is not there yet. Then we hack and develop to make test finally pass. Then we decide that we don't quite like the code, it can be optimized and it can be improved, so we refactor the code. Then it can happen that the tests start failing, so we rinse and repeat this process until all the tests pass. And behavior-driven development kind of adds additional layer of abstraction over test-driven development cycle, in that we initially agree on a feature, we specify the behavior of the software, and we come up with some set of rules and examples how the software should behave. Okay, so I plugged myself in after a brief pause. And here is some tabular recapitulation comparison of test-driven and behavior-driven development. In test-driven development, we focus on implementation of feature. In behavior-driven development, we go a step further and we focus on the behavior of the entire system. We focus on semantics, like what the system does, and not quite so much on how it does it. In test-driven development, this is mostly about developers. In behavior-driven development, we also involve QA, customers, and business analysts, simply everybody in the process. In test-driven development, we work in some programming language of choice. In behavior-driven development, the platform on which we use to communicate, collaborate, and come to some shared conclusion and understanding is simple English with some structure, is this Gherkin domain-specific language. In test-driven development, we focus on delivering the unit tests of the software, and in behavior-driven development, we focus on the shared understanding of the requirements and implementation of the behavior. So there are some 3 phases of the behavior-driven development. I will focus in my talk on the first 2 because the third one, actually implementing the defined behavior, which we collaborate on and define in step 1 and 2, is kind of out of scope of this talk. So in the first phase of behavior-driven development, we create some specification with the focus on the behavior of the software, with the focus on what exactly we want to build and some examples of what we want to build. We communicate using this ubiquitous language and hash out our differences and come to share understanding. And in the second step, we take those examples, the specification of the features and the user stories, and we will turn them into automated tests. So I will now use a couple of slides to present the first step. How do we come to the shared understanding of the software behavior, and how do we create the specification of our features, of our scenarios, and of our steps? So, as we said, we want to bring everybody on the same page. We have some diverse team, which consists of technical and non-technical members. Some of them can code, some can't. Everybody has their strengths, their weaknesses, and we want to involve all of them in the process of creating and delivering the software that the business actually needs and that matches what the users want. So the best way to do it is that we use the language that every single member of this of the development team or of our entire team understands. And if we use a simple language, chances are we avoid miscommunication. We can't completely eliminate it, because every time people communicate, chances are they will misunderstand each other, but we can reduce those misunderstandings using the suitable tools and suitable rules and procedures. And our shared goal is to deliver software that matches the business needs and does what the users want it to do. So here is some quick refresher how the features are some basic units of the software behavior. How are they structured? This feature is written in the simple domain-specific language which is called Gherkin, that I already talked about. And as we can see, it reads as like a user story. It's a simple English. It has some structure. It's split into several parts that have further internal structure. And so the basic unit is the feature. I will show it later, we have some simple address book application in which we can add the users with their name, email address, phone number, maybe snail mail address as well. And our feature, the basic unit of the behavior, is that we want to fill this address book with entries. Each scenario, which is subunit of the feature, describes this feature or in some different set of circumstances, different set of initial conditions, different set of inputs and outputs. And every scenario consists of several steps. How do we actually get where we want to be? Step-by-step process that describes what do we want to achieve. How do we want to get the input the scenario wants with the output the scenario specifies. So we use the simple structure with a couple of keywords that's very similar to natural language. And so we start our discovery process. Discovery in a sense, agreeing on what we want to build, what we want to implement. How does that align with the business needs? How does that align with the technical limitations that the chosen platform, the development team uses, presents? And there are several ways to do it. So how to come to some shared understanding what we want to build. This process I'm describing here can involve many people, like the entire team, but at least those three roles should be present. And the roles are the product owner, the software developer, and the tester. The product owner is someone who knows the business and understands their needs, and who will translate those business needs into the features, into some sets of specifications that need to be built. Software developer, on the other hand, is someone who has in-depth knowledge of programming language or languages and looks at those features presented by product owner and turns them into code. Someone who can actually implement the specified behavior. Tester, quality assurance, is someone who knows the platform limitations, who has a good attention to detail, and who can spot all the corner cases and who can kind of see how the things can break. So if those three kinds of people in those like three different roles work together, they will come up with features consisting of different scenarios, consisting of sets of steps, and everybody will contribute something else to the overall process. So probably product owner will be someone who will define the scope of the application and actually split the user stories or the requirements into single features. Software development, on the other hand, will take those features and add specific steps and many implementation details to the specified scenarios. Tester will come up with corner cases, like add more examples and steps to the scenarios because of the way he can see how the application can possibly break. And after the discovery workshop, when we come up with set of features in which the main focus on discovery workshop or the discovery phase of specifying what we want to build is indeed focusing what we want to build instead of how we want to build it. It's that we define the scenarios and steps by their semantic, like what is being done. Given that we have the address book application, we want to add contacts to the address book. So that's how we specify it. A contact is added to the address book instead of how it's going to be done, instead of kind of focusing or including very specific user interface details that we click on button such and such or we film form such and such. It's really like the focus on the behavior, avoiding using specific technical terms. I read somewhere in one of the behavior development tutorials, it's like working as if it was the year 1922, like no technology is known, and we really have to use the simple language and avoid technical terms to describe what we are doing. And once we come up with the features and scenarios and steps, it is clear to us what we want to do, what we want to build. We can take those steps and those scenarios and refine them with the set of examples. And one way to go about this, to come up with the set of examples and further refine the specification, is that we define the set of rules. And for each rule and for different combination of those rules, we will come up with examples and that actually implement those different inputs and specify the desired outputs. So again, for the address book application in which we are adding the contacts with their snail mail address, with their email address and with their phone number, we can, for example, come up with a set of following rules. So compulsory fields are going to be the name and the surname. Those must be filled under all circumstances. Then at least address or phone number or email has to be present. And if one tries to enter user second time or the third time, this is not going to work. The duplicate names are not allowed. So those are our rules. Also, like the telephone number has to connect of numerical characters, and if not, the error message appears. So those are our rules, and for each rule and for combination of those rules, we can come up with different scenario. So the first simple scenario is obviously adding a single user, and we fill all fields and everything's fine. A second possible scenario could be that we add 2 users, but now we try to add the same user twice. So in a simple language, we specify, and in this like kind of tabular form, we specify what data are we going to fill into our address book form and how the system is going to behave. And we focus on the behavior, what is happening, what is going on, and we skipped out the technical details. So we know that like we add the persons to the address book, but we actually don't specify the user interface details, like the text fields we are going to fill. And also like the output is specified in the very kind of simple way. And yeah, we know that the error is reported, but we are not focusing on the details how this error is going to be reported. So, and if we go about specifying the requirements and discovery process in this very simple way, using the structure of features, scenarios, and steps, communicating within the team responsible for the initial specification, using the simple Gherkin language and those examples, we come up with comprehensive design, and we strive to achieve shared understanding to all parties, independent whether they can or cannot code, what their strengths and weaknesses are, whether they're technical or not. And at the end of the day, everybody should be on the same page. The understanding what needs to be built, how does it going to behave, and what goals do we have and what the limitations are should be shared across the board. And since we are avoiding like specific details, what user interface elements should be involved, or even like what programming language functions should be called, what we also achieve as a side effect is stability. So the feature and the automated tests implementing this behavior are going to remain stable even if the underlying implementation changes. So if we say we add the user, and there are like different means of adding it, so you can add the user by clicking on a toolbar button or like invoking some menu. If the menu is dropped or like toolbar button moves, this test remains stable because it doesn't focuses how it is done but on what is being done. So once we got through the first phase, which is developing the specification, using extensive examples, and communicating in ubiquitous language, it's time for the next step, which is turning those examples into automated tests. Okay, so we turn examples into automated tests. I'm going to switch between my slides and Squish IDE. I'm not going into so many technical details right now, but again, I'm going to focus on this human-centric approach, how using Squish in particular can help you people to implement some best software engineering practices when turning your examples and your BDD features into automated tests. So the first advantage of using Squish is that, or like this is a general advantage of behavior-driven development, that the automated tests are kind of part of the process from the day one. And in Squish in particular, you can create tests even if the application doesn't exist yet, because Squish enables you to insert the dummy implementation of the scenarios and the steps initially with a few clicks of the mouse or the few keyboard shortcuts, so it can be plugged into continuous integration, for example, right away without actually waiting for the code implementing the behavior to be ready. So I will switch to Squish IDE now and show how can I create those dummy implementations of entirely new scenario. So I jumped to, this is the scenario I presented earlier. So we have a feature, we're adding users to the address book, and now I want to create entirely different scenario. There's this warning icon at the edge of Squish IDE, which is somehow indicating that the step exists, but there's no code backing it up. There's no implementation. So I can just keep typing, create entirely new dummy scenario. And for the steps that are not implemented, there's a handy keyboard shortcut. I will right click on the unimplemented step, and that's this context menu that's creating missing step implementations. So I will click on it, and for every step, when I switch back to my feature, for every step that is not implemented or that was not implemented, a dummy function is created. As you can see, the warning icons have now disappeared. So this new feature, new step that I added was not implemented because I just added it. And there's a handy keyboard shortcut which is Ctrl G, which will jump to the actual implementation of this particular step. And we can see Squish added a dummy implementation of the step. So it prints a warning that this step is not implemented, but it passes. So it can be, even if the code is not implemented, it can be plugged into continuous integration, and the test will pass, or like test will work from the day one. We can build on this, and we can continue adding the implementations and refactoring later. So that was the first best software engineering practice that the Squish helps us to implement. The second one is kind of natural modularization of the code. If we go back to the address book, and we looked at the recording of the, so let's see, I will add a new test case. It will be a scripted test case. And I will start recording now. So I will open a new address book. I will add the new user. And another one. I'm happy with the recording. We can see that the code looks like this. It contains lots of duplications. There's just one large main function that like contains everything. It needs some discipline and some kind of fortitude to actually take this recording and refactor code in such a way that's kind of easy to maintain, and that kind of reduces the technical debt. It's kind of not part of the process with the scripted test cases. With the behavior-driven test cases, it's different, because like every scenario every scenario consists of different steps, and for each step there is exactly one function implementing this particular step. So we have one step. I will use the keyboard Ctrl-G shortcut again to skip to the implementation of this particular step and back. So for every step we have a separate function. We also, if we want to use some variation of the data, we can use this kind of tabular form to avoid kind of monolithic and hard to read blocks of code. We can instead for the step implement the function that takes some arguments, as many arguments as we have columns of the table. So if we modularize the code in this way, and if we naturally decompose the complex procedure, which is already part of the process when we have been working together on the feature, we obtain the code that's easy to modify and that's easy to refactor. And so kind of continuing in that vein, we also with the behavior-driven development, we increase the code reuse. So if I jump back to IDE again, sometimes the same steps repeats in different scenarios, and it's always like the same function implementing it. So the same function is used to implement the step here, as well as in the second scenario. So if I create a new scenario, I have to delete the functions that are the dummy implementations that I added to kind of show the point. So if I delete them, save them, we see the steps are unimplemented again. So if I decide to recycle in this particular scenario, if I decide to recycle this step, Squish is kind of helpfully showing me, providing some code completion, like which steps can I recycle. I reuse it in this context. Oops. So, and if I save it, the warning icon disappears because I reused the step, but I don't have to write the code again because it is already written in the previous scenarios. So I just have to, all I have to do when I create a new variation of the scenario, kind of like new test case that reuses several steps, I just have to implement the steps that are not implemented yet. With scripted test cases, this is somehow more cumbersome or more difficult, because if we want to implement a different variation of the same scenario, we have to either record the interactions every time, which produces a lot of duplicate code and somehow increases the technical debt, or we have to use some different way, which is kind of precisely specify the different interactions that are needed in the different scenario, and we will insert the recorded snippet. While with the behavior-driven development, the code is already modularized, and we just have to add the steps that we don't have yet. So, and with the features, with all the code structured, the features, the automated test cases structured like this, we can preserve this test structure also like during the entire software lifecycle. So even if we ran the behavior-driven development tests, we will, instead of long list of test results, we obtain the test results that kind of follow the same structure, that have the features split into scenarios, split into steps, so we can have a look at which features have failed, then kind of drill into details. First we see the bigger picture, and then we looked at like which particular scenarios are the problematic ones, and within the scenarios which particular steps have failed. And so I will switch to IDE again. With the feature written like this, we can, it's like a living documentation now. So we can take it as it is with all the examples and all the scenarios and pass it to technical writers, which kind of add the full sentences, and this is something they can easily work with, and this is something that has like defined structure, the behavior specified in a very simple and very comprehensive way. So this is something they can easily work with, they can expand and follow up on, and kind of create a good quality technical documentation out of this. Of course, there are some gotchas when it comes to behavior-driven development. In comparison to test-driven development, it adds this one more layer of abstraction, which is not necessarily something negative, but it's like more positive or more helpful, because this another layer of abstraction, which is like the features written in Gherkin domain-specific language, close to natural language, serve the purpose of achieving the shared understanding and bringing everyone to the same page, or like in other words, avoiding misunderstanding and avoiding delivering the software the business actually didn't want. Related to that, such a collaboration requires solid communication skills, if not of all the parties, then at least some of them. And if we work in this way, it also requires some discipline, in that we have to stick to the principles that I outlined earlier, which is like to write readable feature files, to collaborate on the feature files, to kind of split the workload across the roles, where business analyst comes with the bigger picture, software developer contributes the steps, and the tester contributes the corner cases. They use the same language that is understandable to everybody, and they can communicate like this effectively. So yes, it somehow doesn't come kind of automatically, and it needs some discipline to stick to those principles, to write feature files in such a way that they're comprehensive, that they avoid the technical details, and to work on those features collaboratively. To conclude my talk, I included some useful links. The first of them is Gherkin reference. It's some reference handbook to the domain-specific language that is used across the board in all the behavior-driven development features and test cases. It contains like the valid syntax, valid keywords, and all the technical details one needs to write those test cases. Here at FrogLogic, we also have an extensive BDD tutorial that guides users step by step through how to write behavior-driven development tests for applications in any toolkit. And of course, there are some. Squish is not the only BDD tool. There are some other tools that can help teams to work in BDD way, and some examples of those are JBehave or Cucumber Studio. So with that, I would conclude my talk. I would thank you people very much for your attention. The slides will be available for download, and I hope you had fun watching, and you learned something new about the behavioral or like the social approach of the behavior-driven development. And I also hope that you will enjoy all the other Squish Days talks that will follow.